Okay, so this next example is just sort of applying what we learned in that last example. And so we're just supposed to find a set of parametric equations for a line through these 2 points, -3, -2, and 3, 4. Okay, now we have to make some assumption about how we want our particle to move along this line. So I'm going to assume that we're going to move from this point to this point in 1 unit of time. Okay, so that's the assumption I'm going to make. And if you make a different assumption, you'll get a different set of parametric equations. It'll represent the same line in the Cartesian coordinate plane. It'll just be a different motion along that line. So, but I think the easiest thing to do is just assume that we're moving from the first point to the second point in 1 unit of time. All right, so so if that's the case, then my dx dt, okay, so my change in x, I'm going up by 6, right? I'm going from -3 to 3. Or I could think of it as, 3 minus a minus 3. That's my delta x, right? And I'm going to move in 1 unit of time. So that's my delta t. And so I get 6. That's the change in x over 1 unit of time. Dy dt, okay, I'm just going to look at how my y value is changing, right? I'm going from -2 to +4. So again, I'm going up by 6. So I can think of it as 4 minus a minus 2 over 1, but it's just going to be 6. Okay, so I'm going 6 units in the x direction in 1 unit of time, and I'm going 6 units in the y direction in 1 unit of time. Okay, so then it's just a matter of saying, okay, well, I'm starting at, let's see, we got to pick a point. We're starting at -3, -2. That's what I assume, that we're starting there. So we're starting at x value of -3, and over each time period, we're going to move 6 units in the positive direction. So that's it. That's my parametric equation. That's the first part of my parametric equation for this line. That's the x value. And then y is just going to be, okay, I'm starting at -2. And again, I'm increasing by 6 units for each unit in time. Okay, so that's the y value of my parametric equations for this line. And, you can test it. If you put in t equals 0, you get -3, -2. So that means you're starting at t equals 0 at -3, -2. And when you put in 1, you end up with the second point, right? You end up with 3, 4. Okay, so you can test that it does work, right? All right, so those are our parametric equations for the line. It doesn't ask us to do Cartesian coordinates, so I guess we're done with that problem. All right, so we got one more topic to cover, and then I'll turn you loose on the discussion questions. So I'll catch you in the next video.